Okay, part C of the problem talks about a different random variable. I'm going to call this one D, even though the problem called it L, whatever. D is equal to 1.5x1 plus 50. What this stands for is diagnosing costs $1.50 a minute. If the person gets the computer diagnosed but doesn't get the problem fixed, the shop charges another $50 flat fee. That's where this $50 comes from. So using our formulas from up here, mu of D is equal to 1.5 times mu of x1 plus 50. So 1.5 times 28.1 plus 50. And that equals, trying something with this program, that I don't like the way that works. Okay, so that equals, let's see, 42.15 plus 50, so 92.15. So on average it will cost $92.15 to diagnose the computer but not let them fix it. The variance then is equal to 1.5 variance of x1. Notice there's no 50. There's no constant here. Remember the formula as I wrote it had a C on the end? Like that? Yeah. No C on the variance or the standard deviation, because when you add the same amount to every item in the distribution, the spread of the distribution doesn't change any. So there is no C there. So that's going to be 1.5 times sigma squared of x1, so times 8.2 squared. And that's going to equal, if we take the square, no, just do the numbers. Do the number real quick on the calculator, so 8.2 squared times, that should be squared, times 1.5 squared is equal to 151.29. So that means sigma is going to be equal to the square root of 151.29, which is 12.3. Okay, and there's question 2. Had a couple of good questions in class today about what do these numbers mean, variance and standard deviation. Again, for all we know right now, all they stand for is a measure of the spread of the distribution. When we start talking about the normal distribution in Chapter 2, which is happening in a couple of weeks, then we'll get a better meaning and a better feel of what sigma really means as far as it applies to a distribution. So just hold tight for that question. We'll answer it in a couple of weeks.